India's premier magazine on building technology, design and sustainability, and Knauf AMF, a leading German company for high-performance ceilings, are pleased to invite all of you today for a nice evening on networking. As all of you know, today we're going to have a panel discussion on aesthetic and acoustic aspects of interior ceilings and wall systems. From the Knauf AMF side, we have here with us today Mr. Andreas Riedel, Sales Director, Asia Pacific and Gulf countries, Mr. Stefan Blockel, Regional Sales Manager, Asia Pacific and Gulf countries, Mr. Teddy D'Souza, Director Operations, Knauf AMF India, Mr. Dipankar Shom and Mr. S. Sundaram. Also from the Buildotech team, we have a lot of people coming in here from Mumbai. I request all of you to please give a big round of applause for them. Discussion, I would request Mr. Andreas Riedel to please brief us on the latest high-performance ceiling materials and systems.
Thank you very much. On behalf of Knauf AMF, warm welcome to this event tonight, to all guests and the Buildotech team. It's a pleasure to be here tonight. Panel discussions are somehow new for us. We did the first one last week in Delhi, and I look very much forward to tonight's panel discussion and see how it goes here. Just a few words about my person. I'm with AMF since 1997, so quite a long time. In India itself, we are since 2004, so we've got our 10 years anniversary. Congratulations to our team here. And it's a pleasure for us to have you here tonight and give you a quick intro into our processes, what we are producing, what we are standing for, and what is our mission. So I've prepared a quick presentation as a kind of intro to give everybody a bit of a feedback about Knauf AMF. And the presentation is mainly built up like a journey on a train with different stops. And please join me on this journey and let's go through it. The first stop which we enter is who we are. The introduction before had a big summary. Knauf AMF is one of the leading manufacturers in the world producing ceiling tiles. We are a member of the Knauf Group. Knauf might be familiar to the one or the other, is one of the leading plasterboard manufacturers, having worldwide more than 25,000 employees. And we produce different solutions for specific applications like fire, acoustics, and many, many more. As part of our history, this shows the real estate or the industrial estate where Knauf AMF is based. We started producing mineral fiber tiles in 1963. So more than 50 years of experience are with us. At these times, at our own, we started producing at our own patent. In 1970, foundation of AMF company. Then in 1985, we got independent from our former mother company who was producing plywood. In 1995, Knauf took over the first 50% of AMF. And at these times, we had a capacity of 10 million square meters. Just 4 years later, we almost doubled our capacity up to 17 million square meters. From 2000 to 2002, there was a long bankruptcy process going on with our former mother company Acoustics, and the red marked area, which belonged to our former mother company, we finally took over, and another milestone happened in 2002. Knauf took over the remaining 50% and paid out the former private owners. This was a big step for us because the one of you who know Knauf know or will know that their main aim is to reinvest whatever is gained from the business throughout the year. And this was for us a very positive effect because then we could really start to invest into new technologies and new machinery. In 2005 we commissioned Factory 2, and at these times we had 50 million square meters of capacity, split it up into 2 factories, which is very important for you to know because we only produce mineral fiber tiles made in Germany. So this is our only facility where we produce tiles, and let's say in the unlikely event of a major shutdown because of whatever reason, we are still able to run our production on factory 1 or 2, depending on which one had the shutdown. And we are still able, of course, to fulfill our acknowledgements. Then in 2006 to 2008 we had further investments into new drying machines, in a lamination line. 2008 was one of our record years all over. In 2011 we started producing grid systems in our premises, which was another milestone. And the last one in 2013, only last year, was the acquisition of Hera Design. There are bags on your tables, there are different product leaflets, literature in there, and for those who has already gone through, Hera Design is, or are the orange, the yellow ones, and it's wood material. So nowadays, a short profile. AMF runs 2 factories for tiles. One is based in Germany, in Grafenau, close to the Czech and Austrian border. The other one is in Ferndorf, in Austria, which is also close to Slovenian and Italian border. In Ferndorf we produce our wood tiles. The total capacity nowadays consists of 65 million square meters and is divided in 60 million square meters mineral fiber and 5 million square meters wood. The grid plants itself have a total capacity of 220 million linear meters, and this is very important for us because we see ourselves as system supplier. We do not just supply individual parts, but we supply systems. The actual number of employees crosses more than 600, and we deliver into 90 countries worldwide, including India. All over the world we run 30 sales branches where we have technical staff to consult and guide our customers. This gives you a short view or a bird view on the factory based in Germany. The one or the other had already had the opportunity to come there, visit us. And this is the other factory, similar landscape, based in Austria. Let's go deeper into the structure and see what we offer. We offer various brands. One, of course, Knauf AMF, which is our corporate brand. Then we have got our product brands, Thermotex, Ventatec and Hera Design. Our target or our target groups are architects, planners, specialized installers and specialized traders. Our know-how is dedicated to various key points. One is sound protection, which we will hear more about later on in the panel discussion. Our experience or our product range reaches from reflecting material up to 1.0 A absorber, high absorbing material or extremely absorbing. And also in the sound attenuation we can come up with products up to 44 dB, so quite a big range. There are lots of other products in between, but this can be obtained from our literature, or as I said before, there will be, I guess, more discussions on this during the panel discussion. Fire is an important factor or an important key factor in our product range. All our products are classified as non-combustible. I think this is also very important to know. We can give certificates for fire resistance up to F120. 120 means in this case up to 2 hours before the ceiling collapses. Very important for emergency routes like corridors. Then we also divide our products into structural and independent fire protection. As far as India is concerned, the structural fire protection in conjunction with the soffit is the main one. Health and hygiene, also a very important topic. We can come up with products achieving clean room certification ISO 3, 4 and 6 as per ISO 14644. There is also an exchange possible into ASTM categories. The US FED standards are categorized in US 100, 1000, 10,000. This is equal to the ISO standards, it's just a different naming. Our products, or some of our products, are washable, damp washable, as well as pressure cleaning, humidity resistance up to RH 100, a very important characteristic. And another one is we have a special application providing a special additive on the surface which makes bacteria and fungi stop growing, especially in humid areas, characteristics which is very often taken. Material and design is also one of our key factors which became more and more important only recently, because planners, developers and architects want to have some more fresh things in the ceiling, not just having these white ceilings anymore. White is more seen for the typical office building, whereas in more modern rooms, in open plan rooms, in sport facilities whatsoever, they want to have some fresh design, and this can be covered or addressed by having special surface designs on the individual tiles. And last but not least, sound, light and e-tech. We do have a special BMX system, special light fittings into the grid, as well as a sound mosaic, which is a speaker system, which is fully covered by the ceiling tiles, non-visible, and comes up with a sound characteristics similar to a Dolby surround system. The product range itself, AMF Thermatex stands for mineral fiber tiles, which are consisting of bio-soluble mineral wool, rock wool, perlite, clay and starch. These four main components are mixed with water and produced on a wet felt process or with a wet felt process. Fire properties and sound properties we already discussed. Another characteristics for mineral fiber is, since mineral fiber comes up with a special density, it has got certain advantages over the soft tiles, for instance. And these are also shown in the air permeability. Air permeability means the air which is going through the tile in case of air conditioning, for instance. So our tiles do have a better density, and they are getting less dark once the building is commenced than, for instance, a soft fiber tile, because this, the filter effect from the air permeability is much less. Various ceiling designs, as I said before, with this Varioline technology are possible. We can do timber applications, we can do metal applications, and even motifs, different motifs, not just reduced or limited to one tile, but also to the entire ceiling of individual rooms. And in total, we have more than 38 different surface designs, which gives you a big variety of choices. Buildotech is our grid T-bar system, also produced in Germany. The outstanding characteristics of this grid is it's a special steel grid with stainless steel connectors, which are very durable. They give you a special audible click to confirm once it's locked in. The lock-in and lock-out process is, you can carry it out endless. It's a special spring steel which doesn't break. And this is, I think, also very important, especially as far as maintenance is concerned. And in conjunction with or in combination with our Thermatex line, it's a full system which we offer, which also comes along with adequate certifications. And last but not least, our hair design range, which is made out from sustainable wood wool and magnesite. It comes up with outstanding acoustic properties, special surfaces. Also, these materials are available in endless color options, which you can see more about in our literature which we circulate. Our products are mainly used in facilities like education, universities, schools, sport facilities, gyms, of course offices or open plenum offices, entertainment, cinemas, then for leisure activities, indoor pools, then in the health industry, in the hospitals and clinics. Another big one which is missing on this presentation is airports. Airports are also one of the main applications which we address to. I mean, one of the big steps or one of the big key facts which we rely on is environmental protection. All our processes are certified as per ISO. First of all, 9001 for quality, and second, ISO 14001 for environmental protection. And as you can see in this slide, or on this slide, environmental protection is categorized in different target sections. One, of course, is the product certification itself. So our products subscribe to various national and international standards. Our product consists of natural material. All these materials which we use for producing our tiles are sourced within a circle of maximum 500 kilometers from factory to reduce carbon emissions. On the transport, we are very much caring about carbon emissions as well. So all our containers, for example, which are leaving to India, are not transported by truck to the next port, because the next seaport from our factory is 800 to 900 kilometers away from us. So we put everything on a train, and the train gets unloaded at the container terminals at the seaport. Then another important thing is building certification. India is mainly subscribing to these LEED certifications. With our products, you can gain certain points for different criteria: energy, closed water cycles, recycling content. All these are main characteristics which we can provide you with details for to gain special credits to get your products or your buildings certified according to LEED. And last but not least, recycling. Under recycling, we understand two different things. One, of course, is a recycling already during the production process. So we recycle 100% of our wastage during production. And at the end of the lifetime or of the life cycle of a product, we are also happy to take back material from job sites and recycle it at our factories. Important to know. This can also gain further lead credits, for instance. This is more or less just a summary from what we just talked about. Communication is one of our key strategies. I had a bit of a chat with some colleagues of you before. What's our strategy in India? And our strategy is, of course, to be as close as possible to our customers. And therefore, we take direct marketing as our main tool. And direct marketing starts here in India. We go to you, we approach you, we consult you, we give you solutions, but also special trainings, facility visits, and hands-on trainings in our factories in Grafenau and Ferndorf. Then we go out on trade fairs. We exhibit latest products, new developments, to keep you in the loop, what's new. And we maintain and run our own R&D center. Some new things. One, which is the main, or one of our key drivers in the market, is the acoustic range. As I introduced before, when I was talking about acoustics, the acoustic range itself has come up with a unique surface or homogeneous surface, which is available as reflecting material up to highest absorbing material. So as a visitor from individual rooms or buildings, you will not locate or see whether it's this or this material. This is defined by the baseboard itself and by different treatments or modifications in the recipe. Ceiling rafts. Ceiling rafts are also a matter which is becoming more and more important. There is this so-called TAP, thermal activated buildings, which are referring on concrete slabs to cool down or heat up, in India more cool down, buildings. And to address also to acoustics, you need to do some more than just this is a perfect option or a solution to address to these acoustic issues which are coming up. They're available in different shapes and sizes, square-edged one, rectangle, curved, convex, concave. Wall absorbers, another big theme or a product range. Wall absorbers are mainly used when the ceiling itself or the floor itself as an absorbing area are not sufficient enough to provide enough absorption area as per the requests, as per the standards or the expectations of the owners. Then the Aquatech, which I mentioned before, is a tile which is RH100, washable, clean room certified, 0.9 NRC. The Vario-line surfaces with the print technology. And last but not least, let me show you some references which we did in the recent past. The majority of these reference projects comes from Europe. It's, as far as India is concerned, it's always a big challenge for us to get permission to take pictures once the products are finished. Although we do have reference projects, so if you're interested in a list of reference projects, feel free to contact our staff here. This was an open plenum office in Netherlands using more than 11,000 square meters of acoustic tiles with a band raster system. Harley-Davidson shops using ceiling rafts made out of Hera design or wood wool. Then an academy in UK using various products out of our range. Baffles is also a perfect solution for acoustic problems. Then another project using Hero Design tiles. Ceiling rafts. The ceiling rafts have been installed after the room was ready, and the customers of this hair salon complained about noisy background, lots of echo and reverberation. So he needed to improve something, and the outcome was used some ceiling rafts and significantly improved the environment inside. Oracle in Netherlands, again a band raster system. The big advantage from band raster system is a reduced exposure system. You need less hangers. You equip the band raster system with planks. Much easier maintenance and installation. Then a school in Berlin, also using curved ceiling rafts. A cinema or Blitz Megaplex cinemas. It's not just one, it's various cinemas which we equipped in Indonesia with black colored acoustic tiles. Then a bowling center in Ukraine, also using the wood tiles to first of all cover the columns, but also the walls and ceilings. And finally, last but not least, we have reached our final destination. I'm happy to hand over to the panel discussion. A warm thank you from my end for listening to me. And if there are some further questions, I'm sure we will have enough time later on to get together and talk to each other. Thank you very much.
Our panelists today include eminent speakers, architects, and acoustic consultant who will give you a rich insight into the critical design strategy and material choices for acoustically sound interiors. I would like to call upon our first panelist, Mr. Kandaswamy Subramanian. I request all of you to please give a big round of applause and welcome him. Is a doctorate in building acoustics from IIT. He has a master's in structural engineering and bachelor's in civil engineering. He has authored a book on architectural acoustics and noise control and has worked on various Indian and international projects. Currently, he is co-authoring another book on architectural and building acoustics and is also a visiting faculty at the School of Architecture and Planning, Anna University. He is also a technician at the Israel Institute of Technology. Can I have a big round of applause for Mr. Kandaswamy? Our next panelist, I would like to call upon the architect, Oscar Consasio. Mr. Oscar, I request you to please come forward. Can I have a big round of applause for Mr. Oscar? Mr. Oscar is a partner at Oscar and Ponni Architects. He has completed his studies in University of Oklahoma and Harvard. He has started his architectural practice from 1996. He is conferred with honorary doctorates from the University of Malaysia and University of Milano for modern architecture and architectural science. He has worked in the US and India for various projects ranging from IT parks, townships, hospitals, hotels, resorts, malls, and corporate offices. Can I have a big round of applause for Mr. Oscar? I would next like to call upon the architect, Mr. Kishore Panikar. I request you to please come forward. Mr. Kishore is a co-founder, architecture head, and has close to 10 years of experience of working on large-scale interior design projects. He has been actively involved in Green Chennai initiative to encourage sustainable practices for the city of Chennai. Joining our panelists, we have also Mr. Teddy D'Souza, Director Operations, Knauf AMF India. Mr. Teddy has 25 years of experience in the building construction industry, and prior to this, he also has 14 years of experience in the aircon industry. Can I have a big round of applause for all our panelists here? Thank you. I would like Mr. Kandasamy to start off the panel discussion.
Thank you. Good evening, ladies and gentlemen. Warm welcome to one and all for this nice evening presentation on the aesthetics and acoustical aspects of the wall paneling and ceilings. It's actually aesthetics and functional, which includes both acoustics and fire protection, because it goes hand in hand together. Because in the previous presentation of Mr. Andreas Riedel, he was talking more on the EN 13501, which is talking about A2S1D0. Because when you talk of A2S1D0 of any product specification, it's actually more or less the acoustics with the fire. Because any interior material, any wall paneling and any material that goes into space today requires minimum of 2 hours fire standards as per National Building Code and as per any codal provisions. Say for example any space. Now I request Mr. Teddy D'Souza, Director of Operations, to start off his first introduction on the panel systems, then will followed by Mr. Oscar and Mr. Kishore will take over and we'll start working on it. Teddy, over to you, please.
And welcome to this evening. Thank you, members of Buildotech, for creating this environment or giving us this platform to have a discussion and bring forth issues related to aesthetics and acoustics in a space. We are here since about 10 years now, and we are trying to always evolve with the industry. And one of the main points that I always bring to the fore is how we present ceilings as a product in the space. I have always noticed in my last decade that we still end up calling the product as a false ceiling. And when you call it as a false ceiling, what you are predominantly doing is, the first thing which comes to your mind is, okay, this is a product which is supposed to hide something on top. And unfortunately, this is not the truth. Nowhere in the world do they call it false ceiling, they call it suspended ceilings. All national building codes are written for suspended ceilings and not for false ceilings.
Acoustically suspended ceilings.
So we have 2 or 3 issues here. Issue number 1 of, if I have to in short say, what does this so-called false ceiling or suspended ceiling do? I would break it down into 3 major requirements of the space itself. 1, acoustics. 2, fire protection. And 3, aesthetics. So really we cannot say which is important. It depends upon the space. But if we follow some codes internationally, then we have noticed that sometimes we find that fire is ahead of aesthetics. Sometimes we find aesthetics is ahead of acoustics, and sometimes it's a mix of all the 3 put together for a given space. For a small example, when we move to a corridor is normally an escape route. And in case of fire, the most crowded space in the building would be the corridor. And therefore, the ceiling in the corridor should not be seen, or I would personally recommend, is not to be seen as what we would do to the other space. We have to find out how to install or how to approach the corridor in such a manner that the ceiling does not collapse. Because if this ceiling of 2 by 2 collapses, then you yourself get entangled in this entire mess and you would not be able to move out. The second thing which comes into play here is the tile itself available or able to withstand the temperatures of fire? Does it give out smoke? And issues of UL classifications under ASTM 823, where we have to check for the spread of flame and also for the smoke that is developed in the product. So this was one of the examples that when you move to a corridor, of course aesthetics is important all over the place, but I would say safety comes first in a corridor, followed by aesthetics. Maybe acoustics is not as important because you are not always looking at this, at getting a perfectly acoustic environment in this space, because most of the time people are just moving on their space. Whereas when you move to a proper office or a private office, the requirement completely changes, because if it is a managing director's office, I don't think, if I would be in that room, I would not want to hear anything that is coming from outside, and I would not want anything which is being discussed inside to be heard outside. So now we have a 360-degree swing. We are not discussing just fire here, but we are discussing a mode which is not predominantly recognized in this country, and this is sound insulation. And there is a myth that absorption resolves all acoustic problems. Let me tell you, it's really not. We are sitting with one of the most eminent acoustic engineers in the country, and he will stand with me on this. Insulation has to be handled first before we move into absorption, because whatever you do inside the room, if you can hear this car honking from outside, we are back to square zero, not even one. So, but when it comes to insulation, we have to go a step forward. Then it is just not only the ceiling, the door, the structure, the partition, the whole gambit comes into play. These are actually some points that I would like to make and hand it over to Mr. Oscar, because he would have a different view of how, and we would want to know a little more from them as to how we should integrate these problems with the basic requirement of aesthetics as well.
Good evening, everyone. Thank you, Dr. Kandaswamy and Mr. D'Souza. Now I'll be talking about acoustics from an architect's point of perspective. As an architect, normally we have four walls on a building, but this is the fifth dimension, the ceiling, which is also the fifth wall of a building. And historically, I think ceilings have been there for the past 100 years, and they were basically false ceilings, so acoustic ceilings were done in such a way. Just look at this ceiling. They're mainly done to hide all the AC ducts, the lighting, all the wires going above the slab or below the slab. Sound insulation and sound absorption are very critical, and they also been a part of LEED credits, because acoustic ceilings are mainly used, which are recyclable materials. Mainly gypsum has been used, and that's recyclable. But if you really look at LEED certification, acoustic I don't think has still come under LEED. I think Dr. Candy can vouch for me.
Most of these materials have become green these days.
But I don't think acoustics has still not been a factor in LEED certification. And
Not
I
yet.
think Dr. Kandaswamy, being a prominent player in India, should vouch for this and try to see that LEED India takes acoustics into consideration.
No, it is a little difficult there. It's a question mark there. LEED India doesn't talk about that.
I think you should justify this to the Indian Green Building Council, and I think even Buildotech should make appeal on this, because acoustics is a major play in all buildings. We have been bombarded with a lot of noise all around building complexes, and acoustics does play a major role. And thanks to Knauf AMF and a lot of other people in the industry, we are trying to curtail this noisy nuisance by using good acoustic partitions, acoustic panels and things like that. Now, as an architect, normally what happens is when we start a design of a building or any inner space, the last thing we think about is acoustics. And whenever we tell clients that we have to really start planning the false ceiling, my wife, architect Pony, will vouch for this, because the money is utilized for the construction, the flooring, the air conditioning. Finally, there's hardly any money left for the wall partitions and the false ceilings. We are doing an auditorium currently as an example, and the civil guy is eaten 4.5 crores of the budget. The air conditioning guy is eaten 2 crores of the budget. The electrical lighting guy is within 1.5 crores of the budget, and my client says the budget he's got is only 8 crores. And Pony is fighting with him. She needs at least 3 crores for the flooring, the acoustics, ceilings, and the partitions. So see, the clients have to be educated, the developers have to be educated that this is a very important factor. The reason being, people live or work in indoor space, and indoor space, you can have more interaction, more human comfort if the noise levels are cut down. Even in the workstations, while planning an office space, the workstations are planned. But around the workstation, no one takes into consideration regarding the acoustics around the workstations. If it is properly planned, you can have more productivity in the workstations as well as in offices. So with this, I think I will also like Architect Panikar to share his views, or else I'll be eating all the time.
Thank you. I think it's a very eminent panel here, and a lot of technical points have been put forth. I'm going to look at this a little differently. I mean, as an architect, and like Architect Oscar also mentioned, for us, priorities are primarily to make sure that the space that we design, is a different kind of a space. And more and more, at least personally speaking, from our practice, we see a trend that we move away from using any kind of suspended ceiling at all, because in spaces in India, especially when you're looking at commercial spaces, you're looking at restricted floor heights. You're looking at something which is maybe 12 feet, if you're lucky. You have structural capitals which come in, structural elements which bring the height down further. So for any architect or for anybody, I think the higher ceiling experience is something that is much more preferred than having a lower ceiling. Now this puts us into a little bit of a situation, because we are moving towards a culture of open office, and more and more partitions are coming down, and more people, more and more of our offices are starting to look much more open, which is a great thing to do, great thing from a culture standpoint. It's just removing barriers between the hierarchies of various people in the office. But it creates a little bit of a strange situation, because you now no longer have too many vertical surfaces to give you sound protection or sound absorption. You're largely depending on the ceiling and the floor. And as an architect, if I want a great space, I would question, whether I can expose the slab, the structural slab, that is, whether I can expose my services. It adds a different dimension to the space. I mean, we've seen airports, most of the time, you have exposed air conditioning ducting, exposed cable trays, exposed lighting, and this adds a very different quality to the interior space. So we are looking at a situation, I mean, this is of course personally speaking, where we are looking at a scenario where we don't have too much of suspended ceiling, we don't have too much of vertical walls. So where do you actually go for acoustic protection? So these are challenges that I think AMF should also probably spend some time thinking about, because we are assuming that suspended ceiling is something that we will have in more offices than not. But if you just look at the way architectural trends are moving, we are moving towards more simplistic, more minimalistic design trends, and which means removal of the unnecessary visually. And also in India, we have a peculiar situation, because we've realized in our projects where we've actually used suspended ceilings, we have greater acoustical issues, not because of the ceiling per se, but the moment you have a suspended ceiling, what goes above the ceiling goes out of sight, and what goes out of sight, there's absolutely no quality control. And that's a very India-specific issue, the kind of issues we have with the quality of labor, etc. So we've realized that the moment you don't have a suspended ceiling, you actually expose everything and it's there for everybody to see, you start getting a better quality of work, because things are exposed, there's no place to hide. Your ducts get finished better, your cable trays get finished better. Room-to-room acoustics improve, because the moment you have an opening in a cabin partition for the duct to go through, if you have a false ceiling or a suspended ceiling below that, you will notice that more often than not the cuts in the partitions don't get sealed as well as they should. But the moment you don't have a suspended ceiling and those ducts are visible and those cuts are visible, it is made sure that the ceiling or the insulation is done accurately. So coming from that standpoint, we are looking at a scenario where we should look beyond suspended ceilings alone. I mean, AMF as a company is already started looking at partitions, looking at wall materials. So it's just a direction we thought we can explore, where we look at solutions other than suspended ceilings, from an acoustic and an aesthetic standpoint. So, Teddy's got something to add to that.
There are two major things I would like to answer. What I gathered from your point is this design element of looking at concrete. This is becoming predominantly very, very famous world over. Not only architectural thought in India, but I have seen spaces in Europe just with plain concrete, and you sit there and wonder how the acoustics is so beautiful, really. So one is the shape of the building itself. So acoustics is not an issue which is settled by the architect after looking at a bare space. It is built in the structure of the building beforehand. The cause of the building or the cause of the space is also decided. So the user knows, am I building a hotel? Am I building a restaurant? Am I building a school? All three spaces have to be then decided or approached differently. A small research I read, or we also then did in a school, we realized that if the acoustics is not right, I'm using the word not right, means we have to find out what should be the reverberation time. If we overkill, we kill the acoustics of the space. If we underkill, we kill. No matter what you do. A little more acoustics will also kill the space, a little less will also kill the space. And we realized that if the acoustics is underrated, what happens is the secondary sound, which is actually an echo, envelops the first one, and then you can't hear the word clearly. And they say that 3 sentences is enough to put you off. Then you are not listening to the subject anymore. You're done. This is a study done abroad. Vice versa, if you go for the overkill and you put a 0.9, you bring the silence of the place so low that if I'm only doing this, then everybody is done. Just a little bit of noise. So one has to balance the place out. We have a few catalogs you can go through for spaces where you want to see more concrete and you don't want to have a continuous membrane dividing the half of the space. We have devised these products called the clouds. The clouds are intermittent acoustic materials which are installed based on the total requirement of acoustics. So it gets a little bit technical, and that's where Dr. Kandaswamy will kick in. These elements have one more advantage. Because they are suspended in free air, it only not gives you acoustic relevance from below, but the back of the tile also starts adding to the acoustic efficiency of the room. So really you're cutting down on the amount of acoustic material that you require in the space. So I have seen restaurants where the cloud would be exactly over the people sitting there. So in this space you would eliminate everything, have 8 clouds, that's it, 8 small clouds. So this is one answer to what will show up more and more, maybe not in open office areas yet, but actually in restaurants and more designer spaces. The other important subject is, Andreas mentioned about the wall absorbers. The wall absorbers are becoming more and more important. So wall absorbers in combination with the clouds will give you a different feel of the space as well. And in our case, we have the ability to take the wall absorber as paintings. You tell us what you want on the painting, we make a digital print of it no matter how big it is and no matter what size it is in. So this might kick in a different dimension of acoustics. But finally it looks like with all the research that is being done, also the baffles. The baffles also give you open ceilings, but they kick in acoustics. Control over acoustics, and this I think is also the future of air conditioning. I would want to bring in one more dimension here, and this is the new thing that is being talked in the industry, and this is thermally activated buildings. Thermally activated buildings are products like chilled beams from the aircon industry, chilled water pipes being embedded within the walls and the structure to pre-cool the area. And then instead of 100 ton, you might actually require just 60 tons to run this place. But what happens in these cases is that the moment you put the membrane, the thermally activated building is not going to act thermally anymore. So here necessarily the ceiling is kicked out. And here we have done some researches to find that the clouds are doing a better job. And slowly this will also come in. So I agree with your point that the 2x2 is not here to stay for a very, very long time, and we will have to evolve as well.
I would like to add to what Mr. D'Souza was saying about open ceilings. If you know, in 1970, there's a very famous building done by Richard Rogers and Renzo Piano. It's called the Pompidou building. They had gone with open ceilings, exposed all the mechanical systems. And thereafter, Norman Foster also did a building in Hong Kong called the Shanghai Bank building. Gone with open ceiling, exposed all the mechanical systems. So open ceilings are also in vogue nowadays.
Actually, on our open office acoustic systems, open office systems, we have a standard which talks about using the acoustical material only on top of the workstations, next to the workstations. And what happens is, the more of the speech intelligibility is being transferred there. So the minimal use of the material is exactly concentrated on the back of the system. So what happens is it's not the reverberation time at 50 seconds, but more of early decay time at 30 seconds and 10 seconds. And you are talking more of the speech transmissibility index. And what happens is, what Mr. Teddy was talking about is the clouds is basically a diffuser kind of state phenomena. What happens in a cloud or a baffle is the part of the energy is being absorbed and it's being thrown down back in a diffusivity state. So what happens, any wavelength cut down happens. So immediately your reverberation time almost slows down. It drops down, and not at 60 but at 30. So you have your perfect speech intelligibility there. So there's no wastage of unnecessary material that is there on the wall in the ceiling system region. We did some job here in Chennai.
Okay.
When we just tested it, it's working well.
And one more thing that comes with the suspended ceiling is that it's though you say suspended ceiling, unconsciously your light fixtures follow the same grid, your air conditioning diffusers follow the same grid. So you're actually setting a pattern for other elements, visual elements to fit into, so you're creating a framework and then everything has to fit into that. So you start limiting in many ways, the creative options that an architect has. So the moment you do away with that, and the cloud is a great idea, you can actually start playing around with not only the ceiling but every other element on the ceiling. So that's a great direction.
We are right now working on a different technology in a project where we are talking about acoustic capacity, like minimal usage of a material inside a space. For example, you have a space here. Now this banquet hall should take only 500 people. So we tell the users that not more than 500 people will be allowed inside the space. So this is something called acoustic capacity, which we tried in one of the space and it has worked out really well. And what is happening is it's a library, and which has got a small museum also inside. And that space, when we sat with the architect, we told the architect that this is what you are supposed to use, and we are now going to predefine the space. It's all open space, and without any ceiling absorbers and all that. And we said this is the acoustic, and it is working well. This is something called acoustic capacity. Right now we are trying it out in another project, and this is what we are advising the client, and also sitting with the architects, explaining it to them. It takes some time because the client doesn't understand. But it works really well because, one, the client doesn't have to spend too much of money, and architecturally, whatever the intent, what the architect feels, you can get in, because you are not dumping so many people inside the space. Wherein the client is also very happy with that.
A couple of points that I would like to raise on your limitability due to the structure. Let's say there is a response from the ceiling industry to these two requirements. One is the monotonicity of 2x2 or the 4x2, whatever you want to call it. And the other is the paleness, if I can use this word, the paleness of the ceiling. You look at it and you see it again and again and again and again. There is no design in it. The fleece in the industry, the fleece that we brought in is a acoustic film that can be put on a surface. This film gives you clean finishes. First of all, it eliminates these so-called fissures. These fissures were not looking too good. Let's say the sensibility has changed. People want to look more plain ceiling, and we have seen this in the market now that more and more people are opting for fleece-coated tiles rather than normal tiles. So you're getting this cleanliness on these tiles. But the fleece gives us one more edge. We can do what we want to do on the fleece. For example, print anything on the fleece. So we can print metal surfaces on the fleece. We can print wood on the fleece. So now this gives you some change from the whiteness that you used to see. Of course, in current context, the technology is a little expensive. But overwhelming volumes can always, like in the past, can also always drag the price down. Another thing about the size or limitlessness or the limitation of the size or cubicles of 2x2 is evolution of the planks. We also supply tiles in formats of 1200 by 300, 1500 by 300, 1800 by 300, and we can go as much as 2400 by 300. So you limit the amount of suspension you use on top. They get on to better looking grids which are more rigid and more supporting, which help fire protection. And you are not looking at the 2x2 anymore per se, and the tiles come so close together at the end of 300 that they are almost overlapping each other and you can't see the grid anymore. So the grid is eliminated. All you see is a white, just a notch, in between two tiles. And if you stand 4 tiles away, the entire ceiling looks seamless. So this is another evolution, and more people are opting for this kind of ceilings.
I got a question for Mr. D'Souza. What is the next generation of ceiling tiles and wall partitions you're working at R&D center? So it'll be useful for architects like us to plan our future buildings in your directions.
Currently, the trend in the past 3 years was to, let's say, take the ceiling closer to the 0.9 and 1. So now we have achieved the NRC 1. So now now we have to start from scratch again. 5 years back, we were looking at the fleece-coated products. We mastered the art of using the fleece on the mineral board. After the fleece came in, we kicked in the printing on the fleece. This started giving us new variation. Now the baffles in the clouds are really the most important things, or we are in the very nascent stage of baffles. We don't understand quite rightly. There are not many tests of what the baffles can really do. We have individual component tests, but when you are moving from a ceiling to a baffle, individual component test is like just testing the wheels and not the engine of the car. So you don't really know what the baffle is doing in the room. It is just anybody's guess as of now, because the number of baffles and distance between two baffles and how they are laid inside the room and the distance from the ceiling as well is a very unique calculation. And for a country like us who doesn't know the calculation for a 2x2, going into these calculations is very, very tricky. But what is on the other side, the manufacturers are trying to evolve a type of a calculation method so that the customer can understand it more in a more simplified manner and can use a pen and paper to arrive to what he wants to use in his space. So I see the baffles and the clouds making a huge impact in the near future.
Again, another question for Mr. D'Souza. I see all over the world, a lot of high-rises, super tall buildings are coming up, 100-story, people are just want to reach the sky. That being the case, when you go higher and higher, architects and structural engineers like Dr. Candy would like to lessen the load on the building. Do you have any suggestions for the interior walls? I'm not talking about the exterior walls. Interior walls where you can have, this acoustic walls, but thinner walls. We can do the partition walls which are waterproof, damp-proof, and they can take care of all the utilities.
Knauf has got a wall system which is actually coming from their plant in UAE, from Ras Al Khaimah. These Knauf walls, most of these walls which is being used in Burj Khalifa is from that plant. We are right now using for a hotel project in Pune, where the inner walls is basically the Knauf wall, and the outer wall is also a Knauf wall.
How thick are they?
They are about 100. We are using 250 outer wall. The inner walls are 100 and 110, and they have amazing acoustic stuff.
What material?
It's just a plasterboard, Knauf plasterboard walls, and they are really good. And in fact, Burj Khalifa, the entire facility is with these walls, and they're really doing well. We are now moving on to these external walls and inner walls of Knauf.
Actually, worldwide also, most of the buildings which are high-rises, and they want the weight of the building to be, structure to be reduced, have moved from regular brick walls or concrete masonry to plasterboards.
So drywall construction.
Yeah, the drywall constructions are becoming more prominent even in India today. And if you see the empty space, all you can see is brick walls or C4X blocks, only where you want partition for bathrooms and toilets. Otherwise, necessarily it's going to this. Having said this brings your question back to acoustics. The problem is the moment you want insulation, you need something dense. Till the time you are discussing absorption, you are discussing something which is lightweight. The moment you start discussing insulation, I'm sorry, but we have to move the dense way. We have no way really. So there is some amount of dependency of denser materials when it comes to insulation. So even if you see the recommended wall partitioning for very high insulations, you will see they talk about 15 plasterboard, followed by DP9 or a 90 kilogram per cubic meter density of rock wool, and then another 15 on the other side. This gives fire protection, this gives insulation. Let's say in India we are not following the standards very strictly, but if you really want...
It's because we don't have a code for acoustics. The earliest code that came out was in 1965, which is still not even added that. There's no code for acoustics. And I don't, normally, we keep telling the codal provisions. I sit on the panel for the pollution control. We don't even have a central pollution control board norms for acoustics on the domestic appliances. Then, the reason what the panel says is, Indians, chalta hai, that's okay. Indians they tend to think that the panelists tend to think that the Indians are more prone. We can take a noise level exposures of till 90 to 100 dB.
Probably because we honk a lot when we drive. We've got some bad habits culturally with respect to acoustics.
As Teddy says, these baffles, it took me a year and a half to convince my client to install 90,000 baffles in a project in Chennai for the Legislative Assembly. And the baffles is still there. That's the largest installation of baffles which we installed, and the technology is the science. We have to prepare scale models for the architects and explain it to them how this baffle will work. Because these clouds baffles are a unique kind of science altogether. You don't require a total acoustical suspended ceiling system. For example, if I want a complete acoustical RT STI value in this space, I just need to put about 6 to 7 clouds or sonic sky in this space, and I can make it more acoustically perfect. Yeah, please.
What is the size of the cloud?
The clouds are necessarily tailor-made. Was that for me? Yeah. The clouds are necessarily tailor-made. They can be in sizes of 1200 by 1200 to 1200 by 2400 in single or multiple models. But be warned, we are still going by what we think is the right solution for a space. Technically, to get out the best of a baffle, I would direct them to go here, because an acoustic consultant is really required, because they have softwares which model a particular space. You give the software an input of what materials you're using inside, what is the optimum crowd you will have inside, for what space you're using, and then you have the ability to move these baffles within this software. They will give you a perfect calculation of what will be your RT at the end of the day. Currently, people who are using these models are people who are going to the acoustics. The rest of them are using it simply because of plain aesthetics. They are doing their job, but they're being currently used as plain aesthetics. Like my initial opening comments of false ceiling versus suspended ceilings, but I'm very happy. I think I made an impact. Everybody said suspended ceilings after that.
Yeah.
Cost?
It's very costly.
I wouldn't say prohibitive, but I would say expensive.
It's very costly. Yeah, that's what I said. It took me a year and a half to convince my client, but the architect was very supportive, and it took me a year and a half to convince my client to install 90,000 baffles.
Yeah, but the moment you're discussing about pieces which are pre-manufactured, then they have to be packed so that they don't get destroyed. And compare it to a 60 by 60 where you put one tile on top of the other tile, pack it into 10 pieces of box, and so tailor-made versus. So I would say keep your fingers crossed on these products. As the volumes increases, there will be more and more competition to drive more and more volumes, and this will help in bringing the price down.
There's something which I really wanted to ask Teddy about. This DEN EN 1350 of 1, 501 of 1 and A2S1D0, which talks about non-combustibility. In fact, what I personally felt during my simulation, my workings on an infrastructure projects, on major infrastructure projects, see, people keep talking about NFPA 130 of 1 standards. See, when you talk about a material for EN 1350 of 1 of A2S1D0, you are talking only about the material, non-combustibility, which is actually NFPA 130 of 1. If you look at the clause 26 of 1 of NFPA, it talks about 2 hours of fire rating. But there is a small test which is to be conducted on the material to make it NFPA 130 of 1.
Yeah. You want me to break all myths in one night, huh?
Yeah, you can still do it.
So all of them will not like me after this. Okay. There is a general question asked in the market always. How many hours can your ceiling withstand? The answer is 5 minutes. The true answer is 5 minutes. And it is not because of the ceiling, it is because of the light fittings that are installed within the ceiling. So if the fire gets to the light ceiling, they say that the light ceiling can only take it for 3.5 minutes. Once the light ceiling is done, the whole ceiling is done. The only way to approach it is to have light boxes behind the light fitting, to ensure that the light box then takes over the charge of the fire once the fitting goes off.
But how many clients are ready to spend money?
No, this is another issue. This will come if the National Building Code comes into existence. This will come. If it hasn't come today, it will come 10 years from now. But it has to come sometime. Having said this, then you have to go by method of elimination. Is the product individually? If I cannot implement it as a system, what can I do to at least ensure that individually the product that I am dealing with him is not adding to the problems or the woes of fire, let's say, if we are discussing fire. And that's where I DIN 13501 kicks in. You have a rating of A2, S1, D0. This necessarily means that the product is withstanding fire to the best of its class. A1 is steel. This is next to steel. S1 denotes that it is in the best index of smoke developed. To give you an example, it's an index of 0 to 100. So 0 is you fire concrete at a given temperature and determine how much smoke it gives out. On the other extreme, you fire timber and you see how much smoke it gives out. So they are both extremes. And then you compare this amount of smoke given out to every product at the same temperature. So when you are at S1, you are at the best level. We are close to smoke levels of actually tested 0. And D0 definitely tells you that even if the product is fired for 15 minutes at 1700 degrees, there will be no droplets falling out of this product. So this is the second level of test. The first level of test is to ensure that you have an integrity in the ceiling when there is a fire. But since we are not following the standards, then you have to take the next level. And the next level is to ensure that the product that you are using is at least not giving you smoke. It is not burning itself. And last but the least, it does not give out droplets, because when people see droplets of sparks falling, they will never tread that path, because there is always a fear that I might catch fire. So this is one level when it comes to the product. At the same time, we have to ensure also that whatever smoke it gives out, because smoke 0 definitely does not mean no smoke at all. Whatever smoke it gives out is not let's say a VOC or is not plastic, so that more people die of smoke than they die of fire. This is really what the fire department also says all over the world, and it is the truth. To this we go back to what the tile is made up of. So if you heard Mr. Andreas's presentation, he said we use only mineral wool, clay, perlite and starch. Starch is a binder. Mineral wool consists of close to 40 to 65% of the product. Clay is used for fire, and this is how we get this D0. Because all of us know that if we put a clay pot in fire, it becomes more and more stronger, it becomes stiffer. It doesn't allow the product to disintegrate. So we put this clay because it then starts hardening the tile up and does not allow it to disintegrate. So this is the approach, really. And the last but not the least, the paint. The paint is the killer for all our competition, because the competition is using acrylate dispersate. They don't have the technology to use something better. Paint made out in our factory, completely 100% water-based. We just put 0.8% acrylate dispersate. This does not give out smoke. And this is why we also have the Blue Angel certificate, which tells us that your product is very, very safe. It's a third-party certificate. They can come to our factory anytime in the year. If they come today, they can also come tomorrow. They can also come in 1 week or not turn up for 3 months. So there is no official information of when they turn up at our factory, and you cannot tell them what they should take. They will take whatever they want to take. And if you are found any different from what you have originally tested or declared in their labs, they discontinue the seal. We have this seal now for almost all our products since the last 4.5 years. And we are the pioneers in the industry to have this seal. It is a third-party guarantee, really.
Mr. Dussel, when you're talking about paint, now hospital environments are changing day by day. There's something called therapeutic environments where false ceilings are being used with color. There's something called color therapy, chromotherapy. Do you have any tiles for hospital environments? Because you talked about paint. So to make the hospital ceilings more colorful.
We are approaching the wellness industry in 2 ways. One is to have a product in the environment which inhibits growth of any bacteria. Okay, so this is the basic level of the product. So what we do is we we mix a compound in this product to ensure that it does not allow any bacteria or fungi to grow in this product. It not only does not allow, it reverses the process and kills the fungi. We have third-party tests for this, and this material is mixed along with the original material when the material is made, and we can put this on, use this material on any of our products. So we can make, no matter whether the product is colorful or non-colorful, it can be used in the hospital industry. We can also go clean rooms, and the necessity for us to do this is to not only address this color therapy. Color therapy is something, yeah, I read about it, but we are not thinking too much about it. I don't know if the Vario line probably can take care of the color therapy, huh? Because if we have the ability to print the tile to whatever colors are ordered by the customer, I think color therapy can be taken care of. But HID is one subject which is coming into big play in modern hospitals. Hospital acquired diseases. You go to hospitals, you are operated, and you come out with MRSA. And then this is a killer, because really they don't have any antibiotics to fight MRSA. And we have noticed, or the industry knows, the building construction industry knows, that most of the components used in buildings are fueling this problem rather than solving this problem. So you have the gypsum boards, which when they get wet, you will see fungus forming on it, huh? And there is no way to clean it. The more water you apply to it, the more you are allowing the fungus to grow, because it thrives on humidity and moisture. The air cons do the job of keeping the humidity low, but it really doesn't help to the core. So we are making products which are Hygiena coated. We also have products which can go up to class 100, which means you can use this product even in operation theaters. And apart from this, after being 100, they don't need to be sealed tiles. They can be the fleece coated tiles, and therefore they can also deliver acoustic requirements even in an operation theater. One speaker in 100 square meters. So this area would necessarily need only, I don't know how big it is, but not more than 2. One here and one there. That's it. You are now eliminating the need for many speakers. So one element which is disturbing to the eye goes off. At the same time, the speaker is there, and I think the bonus is that you can listen to it, or the audibility is far more clearer than what a normal speaker would do.
It's basically dependent on the directivity pattern of how the person is sitting, how the speaker is being placed. Actually, normally what happens is, if you're using a public address system, the normal speech directivity is supposed to be 200 mm. But what happens in India is, Indians have got a tendency of going close to the mic and talking. This is what is happening. You are not supposed to. So the moment, this is the longest distance that you are supposed to have. That's why you have a muffler on top of it, because this has got a directivity pattern. The speaker also works on the same directivity pattern. So this, the 160-degree angle is this angle which throws. So what happens is that when I am talking, I'm now talking, the entire energy is getting wasted. But when I am talking like this, I am actually forcing my energy to the person to whom I am talking to. So you are actually unnecessarily you are actually controlling the energy, you are optimizing the acoustical treatment, then the energy, the speech intelligibility becomes perfect. The reverberation time is desirable.
I would suggest that, I always struggle trying to sell this to airports, because it is a product required at airports. They make swanky airports, but you really can't hear what they're trying to tell you. It's still a big problem. I was in the Mumbai new terminal. No chance. You can't hear. I mean, I always think every person they're calling is me. I don't know whether this feeling is only with me or somebody else.
See, what happens is in airports, you normally talk about the speech transmissibility index, but the main important feature in the airport is, according to the international airport regulation standards, the public address system, in case of an emergency, in case of any emergency, the time taken for the people to be evacuated out from the exit is exactly 1 minute. So at 1 minute you need to have an STI of 0.7, which is prefixed notions. Every material, so that's why you don't use any acoustical material, but we play mainly with electroacoustical stuff. So electroacoustics, there is an important criteria there. You cannot use 3 hours, because in an infrastructure, in a transport corridor, every material has to be 3 hours fire rated as per NFPA 130 norms. So the moment when you have NFPA 130 norms, all acoustical material should comply to 3 hours fire rating. Now, every 10 minutes fire rating cost you $600. Every 1 dB will cost you $800. So any client will not spend. If I say I want an acoustical material of alpha W of 0.9 and a material that has to cut 50 dBA is even more dangerous. There's a cost involved. Every 1 dB is $500, $600. Every 10 minutes fire rating is so much of money. A client is also not interested in doing. At the end of the day, he is putting his capex. There is a capital expense which is being pumped in. There is also an operational expense which he has to take it out. It took GVK almost 15 years to build up that airport. Now he has to take back that money. So for him, he has to minimalize every other stuff. This is even there in Dubai airport. There is even a problem. There is a huge problem in Dubai airport. You cannot hear. I have missed flights in Dubai. This is there. It's not even here. India, it's okay.
Another complication is the volume of the room itself.
Yeah.
When the volume increases, this becomes very tricky to handle. Then you have to zonalize sound. If you are trying to let's say address the whole crowd through common speakers, this becomes very, very tricky. Then you really have to talk about $500 per dB and all this, really, because you're trying to address the entire area, which is humongous volume. And not all the material in the place is acoustic. So
the most beautiful acoustically perfect airport in India is Cochin Airport, which is existing airport. By mistake, or I don't know, fortunately or unfortunately, it has become acoustically perfect. It's the only perfect acoustical airport in the country. Any further questions, please?
You were talking about the partition, no? That exterior and interior partition.
Yeah.
Why they are not using in India?
See, we have.
Is it because of the cost wise or?
See, this one is a cost. One is a cost. And another point is, when you use a partition, a drywall partition in India, first point is the phenomena of sound. First is sound insulation, then we talk of absorption, then we talk of transmission, then we should talk of radiation. Now all this comes in a wall, in a dry wall. So it starts with insulation, then it ends up in radiation. Now when you put an external wall, you first need to understand what is the noise that is going to be generated, that is being generated today, but the point here is, as per EU, European Union Directive 2005, any noise level survey that is to be conducted should not be conducted for that year, but it has to be extrapolated for the next 15 years, because the building is there and the EU directive very clearly talks about every 3 years increase of 10 dBA. A dB is different, a dBA is different. So increase in 10 dBA, so you need to simulate and you have to get the drywall perfectly for that next 15 years of directive. That means today if it is X dBA, after 15 years it will not be that X dBA. It is X plus another 50% of that X. That is for the external wall. Now the internal wall. Now if you talk about the internal wall, the transmission that is taking between the two rooms, and if you had any toilet shafts in between, the toilet shaft service installations have to be taken care of. You have to actually design the wall, how the fixtures are to be fixed inside the wall. You cannot randomly place everything there like what we do it in a brick wall. So all these fixtures have to go into the wall. So that's where the problem is. Now today we have started with this project wherein it's a steel structure and where we are using it. It's going to be a experimental project. But abroad they are still working on it. The masters are Europe. You still have a research which is going on right now done by the European Union where they have invested about 300 million euros where a combined work called COST. COST is actually a experimental initiative given by the European Union wherein the laboratories and, from France and Germany, then from Netherlands, every other country have joined together doing testings on these dry walls with different entities wherein you have a standard. You don't have a standard in India. You don't have. When we work on a project, we work on European standard. We don't work on any other standard, because if you look at the Deutsche standard, the clause talks about you can actually, the first page of the clause, the first page introduction of the clause says, if there is a problem, acoustical problem, you can take the owner to the court of law. This has happened in England. Last year, there was a very tricky case which took place in Ilford in Essex. The Ilford City Council got a case which says there was this apartment dweller who has gone and filed a petition against the next house neighbor because his neighbor's dog was barking and the sound was transmitting inside the room, his house, because it was on the partition wall. It was a new dwelling. And what happened was, immediately the developer was called for, and the contractor who has installed the wall was also called for. And they actually ended up paying the guy who filed a petition for almost 85,000 pounds. This doesn't happen in the country because we are prone to these noise levels. And it's really very tricky. Another point here is workmanship error. In India, how many installers can do a drywall? Workmanship error. There are a lot of workmanship error. Whereas European, you don't get these proper workmanship in Canada also. In US, you still have these problems, but in Europe, you don't get it. They are very perfect because the standards are very strong. You have services standards, you have airborne sound, there is a standard, structure-borne sound, there is a standard. Services for air conditioning services, you have a standard. For shafts, you have a standard. Shafts is for the toilets. For air conditioning shaft, you have a standard. All this is important. Any further questions, please?
Anybody would like to ask anything? Pass the mic.
Yeah, please.
In India, we are more keen into first thing is the cost. People see what would be my budget or something to maybe come out with a hall of interior of a hall. First cost, and then they go into the aesthetics, and then into the technicality, be the acoustics or something. Is there anything being done to impart that acoustic, the technicality of acoustics among the people? Because once that barrier is broken, I think maybe we can bring in our product more, I mean, the volume can increase, and once that particular barrier, the cost barrier is broken, the technicality barrier is broken, people might go into, for like, as we discussed earlier, the open ceiling. People see aesthetics first. They say, no, it wouldn't be pleasant to the eye. But once they go into, like, they are educated on acoustics, they might say, okay, fine, I might leave aesthetics aside to achieve that acoustics. Anything being done to impart that knowledge?
Okay, thanks for the question. Currently we are misguiding the customer. No. Okay, jokes apart. Today the market has also changed in the way it behaves. What happens is most of the time in the wake of volumes or voluminous business per se, the tender is already made, specs are already written, and any twitch we try to do with these specs is seen to be trying to force the architect to change his mind. Nobody likes this. I give you this background because I'm trying to go by method of elimination. So eliminate that we can do anything after the specs are written. This is not possible. We have to reach the architect's table where he does not have a job. Training only happens at that time. That is the time when you can discuss with him, sit with him, first talk about acoustics, if we are discussing acoustics or fire rating, and then talk about how your products are relevant to this acoustical need or this fire need. I think there is a change in how vendors are selling it from what they used to sell this product 5 or 6 years back. There is a change. You will see much more modern products being brought in, and the change is more faster than what it was happening 5 or 6 years back. Because let's say about 5 years back, it was difficult to sell any other size other than 600 by 600. Any other size was trying to misguide the customer. Today the pattern is we are selling close to about 12% to 13% of our total volumes are other than 600 by 600. And this change has happened rampantly in the past 2 to 3 years. So it is for the first person to start talking and the rest follow. And this is a good trend because when they follow, the price starts coming down. Because then you gain volumes in that. And whenever a product turns from a speciality to a volume, we have seen this all the time, the price will always go south. This is good for the customer, this is good for the vendor as well. And this also pushes us to continuously drive towards newer products. So there is some training happening. In the last panel discussion, we got a comment that we should also go to schools and colleges, architectural schools and colleges, and spend some time there so that you train the architects or the future architects. Because acoustics is not a subject yet being discussed in architectural schools. Though I'm a little surprised, I'm not a student of architecture, but if you go to Europe, every structure in history was made keeping in mind architecture. So I'm sure keeping in mind acoustics. And this is what I have noticed, and most of the architects learn a lot from the European architecture. Stop me if I'm wrong. No. So I wonder why they don't talk about acoustics in a space. And a lot of research has gone in the Western world on acoustic requirements, even in schools for that matter. When I said earlier that after the third sentence, the person does not listen, the person is also a student. If you notice, currently in schools, we are more talking about comfortable environment, and our comfortability ends with the aircon system. It does not stretch itself towards acoustics yet. But this will come. I am sure we are chasing a few schools to tell them how they should introduce acoustics, because with the aircon you are actually spoiling the situation, because now you will have a continuous background sound. There will be an aircon making sound continuously, and this will disturb. Therefore we need something to kick in form of acoustics. It could be wall panels, it could be ceilings, it could be, we would find different ways to color the place up. But we need acoustics to come in, because this will bring in a huge amount of let's say, concentration to what the students are really doing. So yes, you are right. We need to put our first foot forward, and we request architects to also listen to us at times, so that then the communication is complete. If one person is talking but the other person is not listening, the communication is not complete. And from our side, the vendors are chasing 0.6, 0.7, 0.8 and 0.9. So it's a little bit of foot forward for both of us. But I have seen the evolution since the last 10 years. So I would say the evolution is for better. It's a little slow, but there is a progress in that.
I would like to thank our delegates and panel members. I'm sure all of us have had an enlightening and a very informative discussion, and all of us have learned a lot from this. I request Mr. Terry D'Souza to distribute the books to our panel members.